So, good morning. Today we are going to learn about is our solar system. Uh, our planetary system that we call home is located in our outer spiral arm of a Milky Way galaxy. So our solar system consists of stars, sun, and everything bounded to it with a gravitational pull. Okay, so let's start with this. That is the solar system. This is how your solar system looks like. Okay, and these are the arms of Orion arm. There are different arms, so because our solar system, or our galaxy, not solar system, our galaxy is a spiral galaxy, and each of these galaxies have our spiral galaxy have a spiral. It looks like a cyclonic storm. All right, so each of there is an arm, like an octopus. It is coming out arms, and each arms are given a name, like precious arm. Then we on the Orion arm, we have our solar system. The arm of the Orion, we have our solar system, that is called the belt of Orion. All right. Then have we have Curix cotton arm. This is a Curix cotton arm. Then this is a Norma arms, and this is Crane Sagittarius arm. There's a constellation here in this solar system. This constellation is you know having Orion the belt. Sorry, the Sagittarian constellation is there in this galaxy. uh, Solar system, that is, we are on the which arms we are on, the arm of Orion, local or Orion arm. Okay, so if you see here, we are just a very minuscule spot in the among in the universe, among these galaxy, the spiral galaxy. Apart from our galaxy, we have many other galaxies, which is moving, expanding with the expanding universe ever since. Okay, so this is the form the arrangement of planets of our solar system. Okay, that is here, starting with Mercury, Venus, Earth, Mars. Then we have asteroid belt. In the asteroid belt, one of the very important asteroid is that Sirius. Then we have Jupiter, Saturn, Uranus, Neptune, and Pluto, which has been recently dropped off as from the status of planet. And at the last, we have Kepler belt, that is also an asteroid belt, Eris. Okay, so now when we are talking about, just hold on. Okay, so now our solar system consists of stars, sun, and everything which is bounded by the gravity. Just hold on one more minute. Okay, right. So when we are talking about bounded by the gravity, the planets like Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, Neptune, and the dwarf planet, which is called which is Pluto. But there are a lot of controversies whether it should be recognized as planet or not, or not a planet. It is still a controversy, but on 2000 uh, one, it is by the international agencies, it has been widely accepted as dropping off from the status of being a planet. All right. Now, there are many, moons, that is the satellite which is revolving around the planets of the solar system, and millions of, asteroids and comets and meteoroids are part of the solar system. Now, beyond our own solar system, there are many more planets that and stars in the universe. So far, we have discovered thousands of planetary systems orbiting um, their own star in the Milky Way, with more planets being found all the time. The most of hundreds of billions of stars in our galaxies are thought to have planets of their own. Okay, and the Milky Way is but one of the perhaps 1 billion galaxies that is there in the universe. Now, while our planet is in some way a mere speck into the the vast expanse of the universe, or the cosmos, for what we say, we have a lot of company out there, that it is expected that there are a lot of life, it seems, to survive. So now we will start talking about the planets and the various cosmic or bodies with this size and the distance. So our solar system extends much more further than the 8 planets that orbits the sun. The solar system also includes the Kepler belt that lies past the Neptune's orbit. Okay, so there is a sparsely occupied ring of icy bodies, almost all smaller than the most of your popular Kepler belt objects, that is the dwarf planets. So most of these icy bodies are very smaller than the planet Pluto. Now, and the beyond fringes of the Kepler belt is also called Oort. Oort cloud, that is this giant spherical shell, surrounds our solar system. It has never been directly observed, but it is exist it is predicted on the basis of mathematical models and observation of the comets that likely originate from beyond that. Okay, so Oort cloud is made of icy pieces of space debris, and the size of the mountains, and sometimes even larger than orbiting larger than the orbiting of the uh, of our sun, as far as about 1.6 light years away from the sun, right? The shell of this materials is very thick and extends from about 5,000 astronomical unit to 1 billion 1 billion astronomical unit. So one astronomical unit is almost about uh, is a distance of like, what is the distance between earth and the sun? That is almost about 150 million kilometers. So one astronomical unit is equal to 150 million kilometers, or you can call 93 million miles. Okay. So Oort cloud is bounded of sun's gravitational influence, and they are orbiting objects that cannot turn around and return close to the sun. So the sun as halosphere does not extend quite as that far. So the halosphere is a bubble created by the solar wind. So a halosphere is, what is a halosphere? So it is a bubble which is created by the solar wind, that is, every now and then solar the surface faces some turmoils, and solar storms occurs, and they emit certain electromagnetic radiations and waves, that is enclosing and like an halo around the sun. So it is a stream of electrically charged gas blowing outwards from sun in all directions. So the boundary where the solar wind is abruptly slows by pressure from the pressure from the interstellar gases, which is called as terminal shock. So the edge occurs between about 80 to 100 astronomical units. So there are many NASA's research that has been going on since 1977, and Voyager 1 in 2004 it was released, and then Voyager 2 in 2007 it was released. But it will be many thousands of years before these two Voyagers exit the Oort cloud, or the last extent of our solar system, right? Now let's coming back to the formation of our solar system, right? So, how did our solar system form? There are many hypotheses. Now, this is the exam. This is what I was talking about. This is the halosphere that reaches till this boundary, but Oort cloud is beyond this. This is small icicle material which is left on the edges of our solar system, and beyond this we have Alpha Centauri, another star which has their own galaxy, their own solar system, and their own planetary system, and all orbiting around it. Now the formation, let's talk about the formations. Our solar system formed about 4.5 billion years ago from a dense cloud of interstellar gases and dust. So the cloud collapsed possibly due to shock waves of nearby exploding star called supernova. So when this dust cloud collapsed, it formed a solar nebula. An alpha spinning, swirling disk of materials, started coming to the center, and they started having its own gravitational pull. And more the gravitational pull increases, the material started condensing furthermore. So eventually, the pressure in the core was so great that the hydrogen atom began to become, started began reacting with each other. So they started combusting. So as we know, hydrogen, when they start combusting, when they started infusing with each other, they converted into helium. Helium furthermore, with pressure again it started combining with each other, and again started another element, that is calcium, and so on. And this what do you call, chain reaction, this infusion of atoms gave and gave out a lot of energy and that's why a sun, or any star for that matter, glows very brightly into the atmosphere. Okay. So now how does they have arranged its structure around the solar system? Now we need to understand that how did these planets started arranging itself around the sun. So, the order and the arrangement of the planet and other bodies in our solar system is due to the way of solar system was formed. That is, the nearest the sun, and only the rocky material could withstand the heat. So, when the solar system was, in its young age, in its primitive age, the first four planets, that is Mercury, Venus, Earth, and Mars, are terrestrial planets. So they are solid rocky materials. So they are small with solid rocky surfaces, and hence they are also called in a planet because after that there is an asteroid belt, and we have, after the asteroid belt, we have Jupiter, Saturn, Neptune, and Uranus and Pluto. Okay. So now, meanwhile, these materials are used to see as icy and liquid. They used to be as an icy, liquid, or gaseous stated in the outer origin of the young solar system. The gravitational pull these material together, and that is where we find these gas giants, like Jupiter, Saturn, uh, and icy giant of Uranus and Neptune in the outer ring of the asteroid belt. So potential life forms, let's talk about what are the rest of the potential life forms that we have. So our solar system is the only place we know that the it harbors life. But the further we explore into the cosmos, we find there is a potential for life to exist on other places, like both Jupiter's moon, that is Europa, and Saturn's moon, like Elucido, they have global salt water and ocean under a thick icy shell. Okay. So if there is a water, it is expected that there could be an existence of life there in these moons of Jupiter and Saturn. Okay. uh, Now, star and its eight planet, that is Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, and Neptune. There are five dwarf planets, or you cannot call it planet, but obviously they are part of solar system. So there are five dwarf planets. Sirius is in asteroid belt just beyond the Mars. Then we have Marmek. Then we have Hamas. Then we have Eris and Pluto. Right. So then apart from that, we have 178 known moons on the planets, like Jupiter, Saturn, and Uranus and Neptune. Okay. Even Earth have got their own moon. Then we have comets. About 3,319 comets are there, and there are 6 million 70,452 asteroids in our solar system. uh, it is located within the Milky Way galaxy. We knew that it is located for about 2,500 light years to the galactic center. Galactic center is this is the galactic center, and we are about 25,000 light years away from the galactic center, and 25,000 years away from the rim of revolving around the rim, outer rim. Again, we are so far from the outer rim that is revolving around uh, the galactic center. Once in about 250 million years we take it to complete the complete revolution around the galactic center. So that is 46 billion year old. It is almost 46 billion, or 5 point 4.5 billion year old. Okay, it's an general estimation of the age of the earth. Sorry. All right. So much of the mass, that is 99.85% of the solar system, is centered at this center, that while an angular momentum is held by the outer planet. Okay, so the larger the feature of the solar system, the larger will be its angular momentum of the outer planets. Now large scale features of solar system, that is orbits of the planets on the same plane and elliptical. So all planets revolve around the sun, we know that. And okay, now let me tell you that they are not circular in path, they are not they are elliptical in path, and they do not move in a same dimension. They have their own different dimensions. So this is what I'm talking about, that each of the planets of our solar system are moving in different dimensions, inclining in a different way. And sometimes they also intersect. Planetary systems do not intersect with um uh, other planet pathway apart from moon and Neptune. And you have a path for Uranus. Actually, basically Pluto uh, crosses, has a certain inclination of its rotation around the sun in such a way that sometimes it crosses the path of various planets while it is taking its revolution around the sun. Okay. So now, this is how it is. Like, if you see, taking from innermost planet to the outermost planet, each of them have their own path of revolving around the sun. All planets are located at an angular interval from the sun, so they are all located at an angular interval. Okay, so when we are talking about angular interval, we are talking about they are having a different dimensions of movement. Most planets rotate and rotate in in a similar direction, like like earth. You have Venus and Mars moving in the similar direction. Similarly, outer planets like Jupiter, Uranus and Neptune moves in that of in the same direction that of Earth, but they all have a different speed of rotation. Okay. uh, Small scale features of the solar system is that there are terrestrial planets, like the inner planets. They have very high density, and they are thin or no atmosphere on the surface. They rotate very slowly. The rocky materials such as silicates, iron, nickel of high melting points. And there is poor ices in ices, and that is hydrogen, nitric acid and chloric and carbon based materials that lower the content of helium and hydrogen and other noble gases. Okay. uh, there's a juvenile world that have low density, thick atmospheres and rotate rapidly. Many natural satellites are there in these, and fluid interior rich in hydrogen and helium, like Saturn, even Jupiter. Most of the outer solar system objects are ice, is more in a form of an ice. All right. So the planets from the solar system, let's have different hypotheses of our solar system. What are the different hypotheses? These hypotheses are, the geologists, the geographers, the philosophers have tried to explain the existence of uh, uh, the existence of the Earth. Right now, or trying to explain the planetary system. Right now, nebula hypothesis was proposed by Immanuel Schutzberg and Immanuel Kant. So Immanuel Kant and Perry Simon Lepsley in 2000, in 1700s, said that a rotating cloud of gas and dust that cools and contracts in the middle to form the sun, and the rest into the disk that became the planet. So it was said that in nebula hypothesis that there was a nebula gas which eventually condensed and contracted, and at the center it became sun, and at the outer edges became a disk, and they further consolidated and solidified, becoming a planet all by its path. Right. Then we have just a minute. Then we nebula hypothesis. This is how it looks like. First, it was a supernova or a big explosion. Nebula gases. Nebula gases then started condensing at the center, forming sun, and they started condensation of primordial dust forms a disc-like shape around the sun. This nebular cloud rotating counterclockwise started furthermore consolidating. So no, this was then called as proton star, or proton sun. Okay, so and the planets began to form around it as it started, forming a clear ring around it, the proton's sun. Then acceleration of the movement of these planetesimal and differentiation of the planet and the moon came into existence as they started revolving and condensing furthermore. They consolidated and became a planet, as the it is evidence from the support of the nebula hypothesis that the planet revolves in a counterclockwise direction. Almost all planets and moons rotate on its axis in the counterclockwise direction. Planetary orbits are aligned along the sun's equatorial planes. Okay, so, now encountering these hypotheses, when it was encountered for the purpose of Camblin and Mullant, it said that the planet formed from the debris or torn off from the sun, and by close encounter from another star. That is, again, this is either tidal hypothesis or proton star hypothesis. Okay, so that our planet, moons, and sun all are spun out of from the collision between the two star. Okay, so that was the hypothesis given by Camillin and Mollant. They said that this is how, when two stars started crossing each other's path, they dragged some materials along its path, and once the star, another moving star, went away, they left the debris on its track, leaving these as a planets to revolve around the next greatest gravitational pulling material in the cosmos. Okay, so this is a more like a tidal hypothesis. Okay, proton star hypothesis developed by the Carl and Witzler and Gerard Kepler. Okay, so what did Gerard Kepler say? Gerard Kepler and the fellow members said tried to explain that the solar system begins to form a rotating cloud or a nebular collapse. But uh, in instability development in the nebula causes the dust particle to pull together, and the dust particle merge into billions of planetesimals, then collide and form protoplanet. So at the center of the nebular disk, the protosun increases in its mass and becomes a star, and by the process of hydrogen fusion, right? But what happens to the planet? uh, like exploration of Mars recently presented an evidence of seasonal flow of liquid water, so in the form of brine water on the surface of the Mars. Okay. Now, Earth Explorer program and the current in the past current decades, what happened is operational was done, like Mars Odyssey, Mars Express, global server. Then you have Mars Recognize Orbit by Italy. In 2000, you have sorry, in 2009 you have Mars TESSAT, and next generation will keep on finding its new way to explore the planetary system in our solar system, right? uh, Taking this further, recent advantages in solar system, that is the Rosette Comet, that is about 675 p for chromovic years. That is it is a Jupiter family comet and composed of two lobes that resembles a pair of snowball structure. Okay. The snowball structure together. Rosette ladder and fillet, touched down on the surface of 12 on 12th November 2014 and became the first spacecraft to land on a comet nucleus. So it was, in 2014, comet nucleus. It was landed by Rosette lander, and these are the objects. These are the flying objects, not people. Uh, Philae and Rosette, lander that touched the surface of the comet nuclei. Okay, so if you see here, you know Rosat is launched in 2004. Then more suitable landing site was found in the process. How this is the trajectory of how it escaped when Earth was here. It started moving away from the Earth atmosphere by taking a circular path. So this is a trajectory that came into existence, and one it merged with the path of the what do you call, the asteroid. It started following the asteroid and kept on giving its information, its pictures through remote sensing technique, back to the earth, that how, what it is, how it is, what are the material, what are the characteristics that was based on this. So Rosat prepares to make comet orbiting robots, that is very like Philae, Rosat. They are all robotics, and they are all machines that have been sent to these surfaces for the further exploration. Okay. uh, okay, now Pluto flyby on 14th July 2015, NASA's New Horizon spacecraft provided mankind the first close-up view of the dwarf planet, that is planet Pluto. No, it reveals a complex terrain, icy mountains, and vast center free plains. The presence of the character free plains suggests that there is recently about at least 100 million years of geological activity that will take place. So almost then the you know m- just almost then the year, over these billion miles, what has happened, this Jupiter in trying to say that New Horizon gets into gravitational assistance, and from the Jupiter to another unique existing science data, or geological data, to back to the Earth. Okay, this is another image showing how trajectory is used to launch a spacecraft to in such a way that it accurately lands or overcomes the other object. Okay, now long no long time, we have to see the quiz for tomorrow. That is, by the end of this lecture, I would like all of you to go to your LMS and take the quiz, so that I am aware that you have understood my lecture completely. Okay, come on. So now we can have a good day and have a very nice enjoyable weekend. All the best.